right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College Application and Website Development Program, or AWD program, I've been doing a series of videos based on the PowerPoint presentations for the book for our AWD1100 Programming Fundamentals with C# class. Here's the book, Numeric C# 7th edition. So far I've done chapters 1, 2, and 3, so I'm finished with section 1, an introduction to Visual Studio. So now we jump into section 2, the C# language fundamentals, and I'm going to pick it up right here with how to work with numeric and string data. So here we are. As always with our Numeric book, it's going to begin with our cover page, how to work with numeric and string data, followed by our applied and our knowledge objectives. Our applied objectives here, working with arithmetic expressions, and you can see all the different variants, so to speak. So we'll talk about declaring variables and constants, which we've looked at already. Working with arithmetic expressions, talking about the math class, generating a random number, casting, which we've done a little bit of, whether you realize it or not. We'll also go in and talk about enumerations, nullable value types, the null coalescing operator. Discuss the difference between variables and constants. Again, we've talked about these a little bit. Ints, doubles, some of the major data types that are in here, really virtually all of the major data types shown there in Knowledge Objective 2. Talk about some terminology, things like literal values, null values, empty strings, etc. Go over the order of precedence for arithmetic operations. And that shouldn't be a surprise. It's probably something you learned in junior high. Distinguish between implicit and explicit casting. Now, with those words, I always look at implicit, meaning that it's done by the software, so it's done for you. With explicit, I'm looking at it that it's done by you, so it's done by the programmer. Finally, distinguish between value types and reference types. And again, as always, with much of this stuff, what you're going to see is it's going to be introduced here, but it'll be discussed in future chapters. All right, talk about toString, parse, try-parse, and differentiate between class scope and method scope. All right, so here you see some of the built-in data types that you have available to you in C#. Now, let's break this page down. Everything on this page, they're all whole numbers. Byte, signed byte, short, unsigned short, int, unsigned int. And it's interesting because what I have found in my career as both a programmer and an instructor, that on this page, out of the 1, 2, 3, 4, 5, 6 different data types, the one you're going to use virtually 99% of the time, will be this one right here, the int, which is a 32-bit integer. And notice it's got a range of -2 billion plus to +2 billion plus. Even though byte makes a lot of sense for small values or sign, like this. Like if I wanted to do people's ages, it would make sense to make it a byte. I don't know if anybody's ever lived to 255 years, but you get the idea. But still, people tend to use ints virtually all the time, and I very rarely myself use byte, sbyte, short, use short, or uint. Now, on this page, the one I use most of the time, again, is a double. Now, you look at these, what are the differences between these? It's range. So, for instance, an integer goes from -2 billion to +2 billion, whereas an unsigned integer goes from 0 to 4 billion plus. With this is this, if you use the absolute value, plus this. All right? Long is for numbers that are so big, I can't tell you what that number is because it's bigger than anything I can imagine. Same thing with float and double. Notice with a float, a non-integer number with 7 digits after the decimal point, the double is 14 digits. I will tell you that when I program, probably 90+% of the time, I use one of 3 variables. And those are for numeric variables: int, double, and decimal. All right, decimal, as you'd probably guess, typically for numeric dollars and cents types of values, okay? Doesn't have to be, but most often it is. Char for a single character, and bool, which is true false. Now, if you say I don't know a bunch of those, again, that's what we're going to be working on in here all semester. So there's the syntax that you see on the screen right now, and there's some examples of declaring these. Now, most often, if you know the value ahead of time, you won't do it like this. You won't say int counter, counter equal 1. This line here that says int counter, that is a variable declaration. You are declaring counter to be a variable of type integer. This line here is a variable initialization. You are saying take the number 1 and assign to it, take the variable counter and assign to it the number 1. Most often, if you know the number in advance that something should be assigned, you combine these into one. So you combine the declaration and the initialization into a single line of code where it would say, for example, int counter equal 1. Okay? So these are variable declarations, and a variable is literally a value that can vary while the program runs. Doesn't mean that it will vary, but it can vary. And that's as opposed to a constant that typically once you set it, it's set and then it's done. You can't change it. Now, some naming conventions. Start your variables with a lowercase letter, then capitalize the first letter after each word. So for instance, if you had a variable named tax rate, it would be little tax, capital R, little ate. That's camel case or camel notation. As it says, try to use meaningful names. I mean, if you've got 3 different variables, you could call them X, Y, and Z, but they may not make as much sense as number 1, number 2, and result, for example. All right, so again, here's examples of both declaring a variable and initializing it on the same line. Now, you can do stuff like this. I don't like this. There's nothing wrong with doing it. This just makes both X and Y integer variables, and they're both initialized to 0. I still do that over 2 lines. I just think it's cleaner code. All right. Constants, on the other hand, and you've heard this before, a constant value is a value that cannot be changed. Now, unlike what they show here, I was always taught that in most programming languages, constants should be all uppercase, which basically sends at least a subliminal message to the user that it's a constant. Here they don't do that. They just capitalize the first letters, and they use what's called Pascal notation. I don't do that. The bottom line is, people always ask, are you really a stickler when it comes to the way that you grade or what you look at in here? What I'm looking for in here is that you start to develop consistency. All right, especially when you're in your first year of school and you're learning to program. It's more important that you program for understandability and consistency. All right, then it is that you have to follow some rule all the time. But if you're consistent, you will be following rules. All right. Here's your arithmetic operators. No surprises in there. The only one that you might not have heard of before is the bottom one, the percent sign, which is the modulo operator. So for instance, if I say 9 divided by 3, there is no remainder, so 9 modulo 3 would give us 0. If I said 9 divided by 4, there's a remainder of 1. So 9 mod 4, or 9% sign 4, would be equal to 1. Addition, subtraction, multiplication, and division, no big surprises there. You cannot divide by 0. And since this is a division operator, you can't modulo by 0 either. Okay? All right, we've got positive and negative, nothing major there. If we want to automatically add 1 to the value of a variable, you can use plus plus. If you want to remove 1 from the value of a variable, you can use minus minus. Now, I don't like to typically break away from these, but I am going to for a moment and show you something here. So let me go and do this. And I'll tell you what, let me do this. I think it's about as big as it can be. If I say int x equals 7, all right? Now, if I want to add 1 to x, I can do this. The worst way to do it is to say x equals x plus 1. It's fine. It'll give us 8, exactly the way you think it would. But it's slow and it's more typing than you have to do. One better way of doing this is to say x plus equals 1, which will also give you 8. All right? But you can also do this. You can say plus plus x, which again will give you 8. Or you can say x plus plus, which again will also give you 8. Now, if you did all these operations, here it would be 8, then 9, then 10, then 11. I'm saying all of these, whether you ran any of those operations after this, any one of these operations singly, they would give you 8. So what's the difference between x plus plus and plus plus x? In this example, there's no difference. But let's come in here and say int y equals 0. All right, now there is a difference between these two. There will be in just a moment. If I say y equals plus plus x, and I say y equals x plus plus, there is a difference between these. All right, this first example means add 1 to x. So again, we're just going to comment these out. We're going to pretend that these are not there. So we're adding 1 to x, which means that x is equal to 8, and then we take that value and assign it to y. So y is also equal to 8. Now in this case right here, this is called the pre-increment operator. You increment and then you assign. This is called the post-increment operator. So when you get done with this, x will be, x will be equal to 8, but y will be equal to 7. Because the first thing you do here is you take the original value of x, which is 7, you assign it to y, and then you add 1 to x. So that's the difference between these. Now, a lot of people say, well, I find that really confusing. You can always break it up into 2 different lines. You don't have to use this. All right, most people will tell you that they do use it because it results in faster running code. In just the same way, you can come in here and say x equals x minus 1, or you can say x minus equal 1, or you can say x minus minus, let's do it this way, minus minus x, or you can say x minus minus. It works exactly the same way as what you saw in here. The only difference is you're subtracting 1 instead of adding 1. So again, this is going to end up giving you 6. So is this. So is this, and so is this. And finally then, if I grab these two, okay, and I make these, instead of plus plus, I make them minus minus. Oops, try that again. You should by now be able to figure this out. This will subtract 1 from x, making it 6. All right, not 68. And then it'll assign it to y. So they're both 6. Again, assuming we didn't do any of this. Okay. This will assign y to x. so y will be 7, then it'll subtract 1 from x, meaning that is 6. And if you can understand that, granted, it's a little different way of looking at things, I get that. But if you can understand that, there's not really any more to this. All right? Nothing really surprising, etc. It's just that these are called auto-incrementer and auto-decrementer. And they only work if you want to go and add or subtract 1. If I want to go in, let's say I want to add 4. So let's say I've got in here int x equals 7, and I want to add 4. I can either say x equals x plus 4, or I can say x plus equal 4, which is a better way of doing it. And there's a plus equals, there is a minus equals, there is a times equals, there is a divide equals, and there is a modulo equals. So again, this is a shortcut for x equals x plus 4. Let me just copy these down and change the sign. All right, this is a shortcut for, whoops, for x equals x minus 4, shortcut for x equal x times 4, x divided by 4, and x modulo 4. One thing you cannot do is you can't do something like this, x plus 4, or plus 4x. That makes, oops, you get the idea. That makes no sense to the system. You cannot do that. These are not allowed. These, use them if they help you. If you don't understand them, wait until you do and then start using them. It's not that big a thing. All right. That's pretty much, I think, has covered this. All right. Works with any kind of variable. And I told you about the equals, the plus equals, times equals, divide equals, divide equals, and modulus equals. Okay? All right. So these are variable assignments. You assign something to a variable. Assign 7 to counter, assign counter to new counter, assign subtotal times 0.2m. We'll get over what the m means in a bit. So assign that to discount amount, subtract discount amount from subtotal, and assign that to total. Now, people read this as counter equals 7. I get it. I read it the same way, but really it means assign the number 7 to the variable counter. All right. Again, examples of shortcut operators. We've already talked about these. All right, here's your order of precedence. The plus plus and the minus minus. All right, those are done first in your order of precedence. Then positive and negative. Then probably, again, what you learned back at junior high. You do multiplication and division before you do addition and subtraction. And since modulus is a type of division, you do them on the third level before, again, you do addition and subtraction. You can always override that via the use of parentheses. Okay? All right. Now, here's casting. And we're going to get into this. You're going to start to see it, but I want to give you an example right here of why you might want to cast. All right, so I'm going to break back out of here and give you an example of why you might want to use casting. All right. So I'm going to come in here and I'm going to declare 3 variables. I'm going to declare, and I know these are, I'll give them better names. So int num1 equals 17. Int num2 equals 27. Int num3 equals 7. 17. There we go. I'll use 17. How about 55? Will that work? No, I don't want to use that. How about 53? There we go. All right, and now I'm going to come in here and say double average equals, and what I want to do is I don't want to do this. I don't want to say num1 plus num2 plus num3 divided by 3. Now, that's wrong for a couple reasons. The main reason it involves the way precedence works. This says do this first. So it's going to take 53 and divide it by 3. Then it'll take the result of 53 divided by 3 and it will add to it 17 and 27. So that won't work. So most people think, well, then I can do this. All right, which is partially correct. It'll add 17 and 27, which is 44 and 93, or 44 and 53, which is 97, and then it'll divide it by 3. Okay, that's fine. All right, but even though we're putting the value into a double like this, this is an integer divided by an integer. It will throw away any numeric remainder. You don't want that. So if the idea is, let's say the answer is supposed to be 32.33333, how do you fix that? There's a couple ways that you can fix it. I can divide this, instead of by 3, I can divide it by 3.0. That should actually work with my semicolon on the end. Or I can come in and do what's called casting. So I can tell it to come in here and do double. Okay? In fact, I may have to put the double in parentheses. They'll explain this in the book. But there's a bunch of ways around this, is what I'm saying. This says add these, convert it to a double, and then divide by 3. All right? So they show an example. I guess I should have just used the one that was in the book here. But notice they've got double grade equal 93. That'll actually convert the value of grade to 93.0. Int letter equal A, that will actually give you probably the ASCII equivalent of A, whatever that is. All right, so double A equal 95, etc. So you've got these 3 values. Okay. Since 1 is a double, this actually should work. But if all 3 of these had been ints, you wouldn't probably get the result that you would want to get. Now, what you see right here, these are referred to as explicit casts, meaning that you do them. You, as a programmer, do them. When I cast 93.75 into an integer, it just throws away the decimal place, even if it's 93.999999, etc. All right, and here's another example. Okay, here's some stuff that you can use in the math class, and this is good because it allows me to bring up something to you. When you're working on this stuff, sooner or later, you're going to come up with something where you won't be in class, but you'll have a question on something. This won't work, that won't work, whatever this or that is. If you go out to docs.microsoft.com, all right? So if you go out there, it'll push you out to this. Right there. But really all you need to type in is this. This is the help. All right? Different kinds of help that you can get for different things. So in other words, let's say that I just did not understand in C#, I did not understand how to do things in the math class. Well, I can come in here and in my search, I can type in C# math class. And it'll show me in here numbers in C#. Here's the math class. There we go, the third one down. And these are the different things that you can do in the math class. They'll actually typically give you in here, they'll give you a program or programs with different examples. Then they'll explain the different methods that you can use. And sometimes there might be 10, 20, 30, 40, or more of these. But for instance, if I wanted to know how to round something, all right, I could click here on round, and there's different ways of rounding. We all know that, but I can click on here, and it'll show me an example. All right, so there's a lot of different ways that you can learn this stuff. Okay, your book is only, no book provides everything. When you've got questions, you go out to docs.microsoft.com. So this allows you to round numbers. This is exponentiation, square root. This allows you to find the biggest or smallest in numbers. Okay, all right. Now, what confuses people, at least sometimes, is it says statements that use static methods of the math class. And it's like, okay, fine. What the heck does that mean? It's a static method. That means that you can call math.round, math.pow, math.square root, math.min, or math.max without having to actually create a math object. That's what static means. You can use the class without having to create an object of the class type. And if you go, I don't get that, you will as time goes on. So here's different ways that you can round. Here is an example of using the Pow function. Now, when you use a language like JavaScript, you could do this. This would work in JavaScript. But in JavaScript, you can also say 5 ***2 to get 25. That particular feature is not yet available. Not yet available in C#. It's one of those things they keep saying they're going to make and then they don't. All right. So next are random numbers. This is a little bit confusing. So it allows me to bring up yet another thing for you to take a look at. Now, some of you in this class were fortunate enough that during this past summer, you were able to take the AWD1100 Web Development Technologies class with Mr. Gudmested, who's a superb instructor. All right. And while you were in there, you probably talked a little bit about things like random numbers. All right. But one of the things that Mr. Gudmested very well likely showed you in here, I'm just going to bring this up again, is our old friend w3schools.com. This is one of the best websites available for you to learn virtually anything that's in this program. So there it is. Now, if you go out to W3, and you don't have to do this, you can just type in w3schools.com. All right? But if I come out here and I go to tutorials, you'll notice that if I look long enough, lo and behold, there's Learn C#. Oh, I'm sorry, I grabbed C++. So let me the next one down. So that's actually then right here. Now this is probably a little bit too big a font. So let me cut it down a little bit. And there you go. So if you go to w3schools.com/CS, just put in that. All right. Let's try that. I'm going to try that into a new window here. That should bring us, and it does, to the C# tutorial. And what's great about this is virtually everything they talk about, they give you a code example, and then there's a try it yourself section. Now there's plenty of other C# sites, and there's a lot of fantastic ones out there. You don't want to get lost in this because there's so many things to look at. Just pick one. This is a good one to at least start with. All right. So the other thing is, about this, let's assume that I want to create a random number, and I want that random number to be between 1 and 100, 0 and 100. I'm going to do someone's grade. Okay? Well, one way, we can always go back to our good buddy Google and type in C# random number between, let's say, 0 and 100. All right, and almost always, not here, but one of the ones, you're going to get one of two things. You're going to either get Stack Overflow, all right, and Stack Overflow in a way, is kind of like Facebook for geeks, all right, because it's designed to answer programmatic questions. But typically, you might have to look a while. But notice there's the random class under our docs.microsoft.com. All right. And I'm going to literally just grab the one here from Stack Overflow and open that. But I want to come in here and say this. I'm going to say W3 schools, C# random number. And notice what I get. Boom. Well, I guess that's grepper, which I don't really want. So let's see. There we go. That's JavaScript random. Well, this is a W3 Schools blog for a random number. But you can see it right there. All right. Let's just jump over to the one from Stack Overflow. What you typically want to do with Stack Overflow is you want to check in here and see if any of the answers that have been given in here have got a green check mark by them. That means it's been the acceptable answer. Okay. Now look at this. Can you show us the code that you tried? They don't want you to just come in here and ask random questions. People will come back and say that's a stupid question or whatever in here. All right. But here's an example. There's to give you a random number. It will between, in this case, 0 and 999. So if I wanted a random number that was between 1, let's say 0 and 100. So I'm going to do grades. I would do this, and then I would come in here 0, and I would say 100 and 1. That will give me random numbers between 0 and 100. It does not include the number on the end. All right. So what is this? Well, we're going to learn more about this really in Chapter 12. But in order to use the random number function, you've got to generate a random number or a random object. That's what that's doing. Okay. All right, let's continue on then. Oops, well, we're at 33 minutes already, so I got to step it up a little bit here. All right. So, as always, they'll come in here and show you some examples. Okay. Very similar to stuff that I just did. There is a number.next. There's different ways that you can do this. Okay. I showed you a way. I'm not saying it's the only way. And I'll tell you what, I'm going to break this up, this particular lecture, I'm going to break it up into 2 lectures because I only like the lectures to average around 30 to 40 minutes each, and I'm around in the middle of that around 35 minutes. So I'll pick it up in just a moment under how to declare and initialize a string.